It's incredibly easy to look at the output of a modern AI tool and just assume it's running on pure magic. You type in a prompt, and boom, out pops a perfectly formatted essay or a stunning photorealistic image. But the truth is, AI isn't magic at all. It's architecture. And if you actually want to build with it, scale it, or deploy it securely within an enterprise, you don't need a magic wand, you need blueprints. Welcome to The Explainer, where we turn complex data into clear, actionable visual structures. Today, we're diving right into the official Cisco AI Technical Practitioner Blueprint, specifically version 1.0 of Exam 810110. This document essentially outlines the absolute must-know mechanics for anyone looking to certify their AI engineering skills. This explainer breaks down the foundational AI mechanics covered directly in that syllabus, and we're keeping it entirely neutral, focusing purely on the technical standards they've laid out. Okay, here's a quick look at our roadmap for today. We'll start with model families and hubs, move into cloud versus local hosting, and finish up with tokens and context. All right, let's jump straight into section 1, the foundation. The Cisco blueprint cleanly splits the entire generative landscape into two distinct architectural families. On one side, we have large language models, or LLMs. These are basically statistical engines built for sequential prediction and logic. And on the other side, we have diffusion models. These learn to construct highly detailed visual or audio data by essentially reversing structural noise. Now, what's fascinating is how these underlying architectural differences drive entirely distinct, practical use cases out in the real world. According to the Cisco blueprint, when you're architecting a solution for something like text summarization or rapid code generation, you absolutely deploy an LLM. Its sequential text predictive nature makes it the perfect tool for logic and language. But if your goal is generating complex pixel-by-pixel images from scratch, well, using an LLM for that is kind of like trying to paint a masterpiece using a spreadsheet. You've got to pivot to a diffusion model. So once you know your family, you need to pick the specific model. Think of AI model hubs as your ultimate digital hardware store. Selecting the right tool there depends strictly on your project's specific requirements. Are you building a customer service bot that needs some really high-level logical deduction? Then you'll want to sort your hub search for strong reasoning capabilities. Or maybe you're building an app where a user uploads a photo and asks a text-based question about it. In that case, your absolute requirement is multimodality support, meaning a model that can seamlessly handle both text and image inputs at the exact same time. Moving right along to section 2, the real estate. Before we get into the nitty-gritty engineering trade-offs, you have to ask yourself one absolutely critical architectural question regarding your deployment environment. And that is, where should your AI actually live? This single decision literally dictates the entire trajectory of your project's budget, speed, and security. Every deployment is basically a ruthless compromise across 4 exam-critical pillars. First up, cost. Cloud turns your capital expenses into operating expenses, while going local requires a massive upfront GPU investment. Second is latency. Cloud deployments are always going to be bottlenecked by network speeds, whereas local is virtually instantaneous. Third, we have privacy. Cloud means relying on offsite vetting, but local gives you total data sovereignty. And finally, scalability. Cloud gives you practically infinite room to grow, while a local setup leaves you hard-capped by whatever physical server racks you actually own. Which brings us to section 3, the engine room. Let's zoom in on the first major mechanical constraint here, which is the context window. It's this invisible, strictly defined boundary that dictates exactly how much information the model can retain at once. You can really just think of it like a human's working memory. If a model has a small context window and you feed it a 50-page document, it's basically going to forget the beginning of the text by the time it reaches the end. So managing this window is a huge, everyday task for an AI practitioner. Now, it is super important we don't mix up the context window with tokens. That's a really common engineering trap. If the context window is the memory space, tokens are the actual fragments of raw data that fill up that space. A token might be a whole word, part of a word, or sometimes even just a single character. Every single model has strict token limits on how much raw data fuel it can ingest in a single prompt, and exactly how much it can output in its response. Let's actually trace how this token constraint plays out step by step in a real interaction. It all starts with the user's prompt. Instantly, the system performs a token calculation. It breaks the text down, checks it against the context window, and makes sure to reserve enough space for the answer. Only after this strict mathematical check passes does output generation actually begin. If you mismanage this flow, your system is either going to crash from overflow or it'll awkwardly cut off right in the middle of a sentence. Tying these micromechanics back to the macro picture, managing your tokens effectively is exactly what controls those cost and latency trade-offs we talked about during the cloud versus local debate. The Cisco blueprint highlights this directly. Token usage and context window management directly impact your prototyping costs and your latency. In the cloud, you are billed per token. If you send bloated prompts, it's literally like paying for excess baggage on every single API call. Your bill is going to skyrocket and your latency will crawl to a halt. At the end of the day, efficient architecture simply means efficient token management. So we've decoded the blueprints today, from foundational model families all the way to hosting environments down to the granular day-to-day management of tokens. The rules of the architecture are set. The only question left for you is, how will you balance cost, privacy, and speed in your next AI deployment?